Okay. Where's Alexis Webster? Alexis. Oh, there you are. Did you get started? Tell me, just how did you get started? Okay, so that's a couple steps there. First, I want to rewrite tan x. So instead of tan x, we're going to do what?
Sine over cosine.
All right. And so don't skip any steps. Just the very first thing that you did. You kind of did a little work after the first step.
Okay. And then use the quotient rule.
Okay.
Okay. So cosine
Cosine, low, okay.
f times the derivative of sine, which is cosine.
Good. Low D high, there's low D high, okay.
Minus sine, and then the derivative of cosine, which is the other side.
Good. Applying the quotient rule. Low, or the denominator, times D high, or the derivative of the numerator, minus high, D low. Sine times derivative of cosine, which is negative sine, or cosine squared. And so this falls out pretty quick. Robin, Durant, did you get it from there? Where's Robin? Tell me.
Right here. And then it goes cosine x squared plus sine x squared all over cosine x squared.
Okay, so just for notation for these trig functions, when you have square, you could write it this way, like that, or you could write it, that means that this is the same as this. It means takes the cosine of x and then square it. But watch out for this. This does not mean the same thing as those two things. That means square x first and then evaluate the cosine. So you either got to have parentheses or put the square next to the cosine part. So watch out for doing that. That's because that does not mean what we intend. We mean this. Okay, so you said cosine squared, then what?
Plus sine squared all over cosine squared. And the numerator will simplify to 1.
And that, by definition, secant is 1 over cosine. Secant is 1 over cosine. So 1 over cosine squared is secant squared. Got it. Okay, just a brief mention here about proofs. When you prove something, you don't start declaring the thing you're trying to prove, okay? So rather you want to have it structure it like this. This is one valid structure of a proof, where you start with one side of what you're proving, and you can deduce that it equals B equals C, until you get the other side. So you make a chain of equality, and then the conclusion is that the first equals the last. But don't ever start a proof declaring the thing you're trying to prove, because that's the thing you're trying to prove. You can't say that. So instead, work on one side, making valid changes to keep the equality until you reach the other side, and then by the chain of equality, the first equals the last. So that would be one valid method for a proof. Questions on using the product rule? Okay, so now we're ready to try some harder ones where the rules are more in combination, and this is kind of the name of the game. If you can do this, you can do anything, okay? If you can do the rules in combination correctly, then you are a master.
It is.
So let's start with this one. Okay? And what is the first thing that we ask? What's that? What's it? Yeah, in totality, what is this function? Is it something to a power? Is it square root? Is it a quotient? Is it a product? Is it a sum? What's the overall structure of this function g?
It's a quotient.
It's a quotient, right? It's a quotient. So the overall structure of the derivative will be the quotient rule. And within the quotient rule, we'll have other rules at work. Okay? So if the overall structure of the function is a quotient, then we're going to start by thinking about this as the quotient rule. So what should we say? We can call the top, say, n of x, say, for numerator. There's nothing magic about these names. And say d of x for denominator. Okay, so n of x and d of x. And so what will the structure of our answer be? What will the structure of our answer be if we're calling the numerator n and the denominator d?
Nx d prime of x minus no.
So you haven't sang the song enough, right? Where is Melissa Imperial? Yeah, can you tell me, so what will the overall structure of the, just in terms of n and d? Which one? Okay. So our answer is going to look like that. Now we just have to find and assemble the pieces, right? So our answer is going to be that. Because the function g is a quotient, the answer will be the quotient rule. And so all we need really is what? We need n prime and d prime, or the derivative of n and the derivative of d. And then we can think of those as their own separate problems, right? Think of those as their own separate problems. So just look at n. Come over here, say n of x is the log base 2 of 4x. And just forget about the whole quotient thing and just focus on n function and do that. What's the structure of that? Sorry, do the derivative of that. So we need n prime. And to do n prime, we're going to think about the structure of that one. What is the rate of change or the derivative of log base 2 of 4x? Volunteer. Yes, sir.
1 over 4x natural log of 2.
1 over 4x times natural log of 2. How do you do?
Good.
I heard good and I heard perfect.
That works.
And that works. But it's not right.
No.
So it's almost. Why? Because yes, that's a log function, but it's a composition, right? It's a composition. There's not just x, but 4x. So you have an interior function. So we just need one more thing, right? So this is the rate of change of the exterior, right? So we need times the rate of change of 4x. So watch out. Make sure you identify when you have a composite function. If you have a composite function, you need the chain rule. Everyone see that? Okay, then what's the overall structure of D? Difference of functions. So our rate of change will be the difference of the rates of change, right? That's the easy one. That's the easy rule. 3 to the radical x. Somebody new, volunteer to do that one. Yes, sir? Okay. Okay, you got the right idea, but you're right. You're trying to apply the chain rule. That's good, but we got to get the exterior function right first. So yeah, so the rate of change of an exponential is just the exponential, but then times ln of what? The base, right? So that's the exterior. Now we're applying the chain rule after that. Now we got to do it times the rate of change of the interior, or times the derivative of the interior, which is 1 over 2 square root of x. So yeah, you had the right idea. You just kind of combined it too fast. Do you see it now? A little better? Okay. So that's the rate of change of that, and then minus. So we just got to remember what's the rule for cosecant? Negative cosecant x times cotangent. Just got to memorize it. So now that we have the rate of change of the numerator correct and the rate of change of the denominator correct, and we know that the overall structure will be the quotient rule, now we just got to write it down. Just put everything where it belongs. We got all the pieces, assemble the pieces. We got it. So it's a lot of writing, but it's easy from here, right? If we got those individual derivatives correct, we got to write a lot, but it's easy from there. Here we go. D of x is? So low, D high, minus, high, D low, which is this whole thing. I'm going to cheat. Over low squared. Anybody have a question on what I did? Does it make sense? So this is kind of the name of the game. They get a little harder than this, just because there's more to keep track of, more to write. But this is the general idea that we've got within the quotient rule. We had the rule for log. We had chain rule. We had the rule for exponential, and we had the rule for cosecant, all within the chain rule. Okay, or all within the quotient rule. But that's how these go. Yeah. Because it's just the quotient rule is just divided by denominator squared. There's no rate of change. You just rewrite the denominator squared. Yeah, see it? Yeah. Okay, any other questions? All right, let's practice. Here we go. Go. Okay,
It's
chain rule, that's true.
square root.
Square root. So what I recommend is write something like this. And now let's write the answer. So given that it's a square root of something, let's write the answer. What's the answer going to be? 1 over 2 square root of that. Then by the chain rule times the rate of change of that. Now I have it flipped. In this particular example, I went inside out instead of outside in. So this is inside out. So the rate of change of the inside times the rate of change of the outside with respect to the inside. So if you just flip those, that might be more what you're used to, but you can do these chain rule problems inside out or outside in. So what I really recommend is don't start writing the answer, because then you can get tripped up. This can really help you so we know our answer is going to look like that. We just have to figure out now what g prime of x is. Okay, keep going. Keep going. So, did you do that, or did you just dive in and maybe got lost in the middle? matter, either way.
Yeah.
Anybody have a question? Product. Yeah. If it's a product, you got to do the product.
Yeah.
You get to one more, so let's see how you did on this one. So, if you start this way, the only work that's left to be done now is do the rate of change of the interior, what we're calling G prime. So what is the structure of that? Sums, right? So sum, those are easy, right? We just do the rate of change of the first plus the rate of change of the second. What's the first? So when we get to the rate of change of the first thing to add, that itself is a product. So we're going to do the rate of change of that. We need the product rule. So we're going to do first times the derivative of the second plus second times the derivative of the first. And then derivative of plus derivative of sine is cosine. So here's the derivative of the interior. That's the derivative of the interior. And so now we just assemble this thing. Or you might have read it this way. This is just A times B is the same as B times A, right? Either way. So that the first is inside out chain rule. Second one's outside in chain rule, okay? So we just have to assemble it. So I have it here as inside out. So the rate of change of G, which we found up here to the right, times 1 over 2 times square root of G. Is it making sense? Anybody have a question? Let's get one more example in here. Can I take this one off? Last chance. Question. Go. Remember the way I recommend that you think about it to start. Okay. So let me put it up. Some of you are not done. We gotta go. Here we go. So we know the answer is going to be this. It's going to be P W prime plus W P prime. That's what the answer is going to look like. So now we just got to find each of those four pieces and plug them in. We already got P and W, so we need P prime and W prime. So first of all, that's P. P prime is, sorry, so that's P prime, which is chain rule. It's something to the ninth. It's a function to the ninth. So you're going to have 9 times that function to the 8th times the rate of change of that function. I'm just doing it inside out instead. So I did the rate of change of the inside times 9 times the function to the 8th. What about W? W itself is another chain rule. It's e to a function. Okay, go ahead and whisper. Go ahead and whisper if you're helping out. So the rate of change of e to the 6 radical x, well, that's like e to the g of x. That's a composite function. We need the chain rule. So it's the rate of change of the interior times the rate of change of the exterior. Just that. And then we can just plug everything in. I'll leave it up on the screen if you want to keep working on it or ask me on the way out.